The combustion reaction we're doing involves butane and oxygen, and some of the products of it is carbon dioxide and water, and it's used in lighters like these, and also you'll find it in a lot of stoves. So you turn this baby on, and that would be butane right there to get it lit. So cooking your eggs and stuff, butane's one of the uses for that.
So before we can do our chemical reaction, we have to see if the equation is balanced. And if you take a look here, you have your carbon, you have 4 on the left side and 2 on the right side, so you already know it's not balanced. So to balance the combustion reaction, you do the method of 2-chore. So what first step to 2-chore is you put a 2 in front of the equation. The next step is to balance your carbons. So we have 8 on this side and 1 on this side, so we need to put an 8 here. So now the carbons are balanced. Next up, balance the hydrogen. 2 times 10 is 20, 20 on this side. We have 2 on this side, so you need to put a 10 here. Now those are balanced. The last step is oxygen, which is the most difficult step because we have 2 here, and right now we have 16 over here and 10 over here. So 16 plus 10 is 26. 26 divided by 2 is 13, so we need 13 over here. Those are now balanced. The last step in 2-chore is to reduce, and since we have an odd number as one of the coefficients, you know it can't be reduced any further, so that's done. And one more quick check through. 8 carbons, 20 hydrogens, 20 hydrogens, 26 oxygens, and 26 oxygens. So now the equation is balanced.
Now that we have the balanced equation up here, we have to do the stoichiometry problem. And the problem is, if you burn off 120 grams of butane, how many grams of water do you get? So here's 120 grams of butane, and to start off, we have to write 1 mole of C4H10. Then we have to do the molar mass underneath it, which would be carbon is 12 each, so it's 48, so you have to multiply it by 4. And then hydrogen is 1, and you multiply that by 10, and you get 10.12. And you add those together to get 58.12 grams of C4H10. And then you do the ratio of butane to water, and you have to cancel these two out, so the 2 moles of C4H10 goes down here because 2 moles equals 10 moles of H2O. And then you have to do the molar mass of the water, so these two have to cancel out, so you do 1 mole of H2O, and then you do the molar mass, which is up here. So H2 is 2.016, and oxygen is 16 for one of them. Add those together, you get 18.016. Then what you have to do is you have to multiply, you multiply the top, you multiply the bottom, and then you divide those two numbers, and that would be 120 times 18.016 divided by 58.12 times 2, and that is 120 times 18.016, 2,161.92 divided by 58.12 times 2, 116.24, which equals 18.59 grams of H2O. And that is your answer of how much water you get for that reaction.
Butane is a common fuel, and it's often mixed with other gases such as propane. It's used in lighters such as this. like you saw earlier, and as well as stoves and grills. So there's a lot of common uses for it. And so this would be an example of a butane reaction right here. Pretty cool, right?